Hi, this is Dan Petrock, and made this quick video to help you with this pre-calc problem. It gets a little messy here, and I apologize for that, but it was pretty straightforward. You're going to take this original function g of x, which is x minus 1 over x plus 2, and we're going to apply this process of finding g of a plus t. So think of it as g of x plus a little more minus the original g of x. So that's like the change in y over the change in x. So we're going to add this little bit extra. That's where you're headed with this for calculus thinking anyway. But just to get in practice on the algebra here, which is usually the hang-up when it does come to calc, is just the algebra issues. So what we've got here is just to demonstrate, instead of g of x here, we want g of a plus t. So instead of having an x, you just put in a plus t. So it's going to be a plus t minus 1 and a plus t plus 2. So this is that part. So when it says g of a plus t, I've replaced it right here. So I just kind of substitute that right in there, minus the original function with a now instead of x. So it's just a minus 1 over a plus 2. Now, this pretty much everything from now on is just trying to simplify this ugly thing. And of course, the whole thing is still all over t. So we just find the common denominator, which is a plus t plus 2 times a plus t. So that's what this is. You take this numerator times this denominator, and this numerator times this denominator. So that's what that big, ugly, nasty thing is right there. And then the t is in the denominator. So a quick and easy way to get that thing up there is to multiply by 1 over t times over 1 over t. This is the same thing as multiplying by 1. Essentially, you're taking the t from the denominator here and putting it on the denominator up here, because the 1 over t, these t's reduce, and you still have 1 over t here. So this is why down here we have the t. Hope that makes sense. And then the rest is a bunch of foiling all this out. So you take a times everything here, 2 times everything here, a times everything here, negative 1 times everything here. So that's what this big long thing is written all out. Notice I've left this negative out front because that's where some errors can happen. So I've just left that negative and kept that whole thing in parentheses. So this right here is the distribution of that. This right here is the distribution of that. And I've just left the denominator the same to keep it clean. Now, if we distribute this negative through everything here, that's what we get. And then we get to essentially a bunch of things will reduce out or sum to 0. So we've got, like this a squared and this negative a squared gone. A plus at, negative at, gone. Negative a, positive 2a, negative 2a, negative 2, positive 2. So all we end up with here is just a t here and 2 t's here, which gives us 3 t's. And then the denominator is the same. The t's reduce to 1's. So our final answer is just going to be 3 over a plus t plus 2 over a plus 2. Now if that needs to be foiled out, then take the a times everything, the t times everything, the 2 times everything. But if you think of this, where it's headed is, and I'll just kind of allude to where this is going, if I take the limit as t approaches 0, so as we get almost no difference in x, what's going to happen is the t will end up becoming 0, and you're going to end up with 3 over a plus t, a plus t, and then, I'm sorry, a plus 2, a plus 2 times a plus 2. And then if you know what a is, let's say when we want to find the derivative where a is 1, we just have to substitute in there and it would tell us the slope at that point, which is really cool. So that's where you're headed with this. I don't know if you really need that part, but hope that video helps.